We are talking about slope intercept for, but we're just going to focus on the slope piece to begin with. And our goal for today is just figuring out the slope of a line. How can we find it? There's going to be, we can do it just by counting on a graph. I'm going to show you kind of a subtraction way to do it. But first, slope is, we use the letter M when we're talking about slope. So anytime you see the variable M, it refers to the slope of something. And a slope is just a non-vertical line. So that means it's a diagonal and doesn't go straight up and down. And it passes through two different points on a graph. And the slope just compares the change in your y value, so how much from point to point you went up or down, and divided by your change in your x value, so how much you went left or how much you went to the right. So you can write this a bunch of different ways. Like I said, slope is the same thing as using the variable m. We always use m for slope. We don't really use m for anything else. We call it the rise divided by the run, because if you're going up on your y's, you're rising or you're sinking, depending whether you're going up or down. And we call going to the left or the right our run. This is the same thing as saying, okay, we're measuring the distance between our two y values, or our change in our y values, divided by the change in our x values. And how do we find the change or the difference between two numbers? Well, we use subtraction. So you can subtract this y2 means that, okay, we're going to have 1 point and then another point. This y with the subscript of 2 just says we're talking about the second point. This x2 we're talking about the second point. We're subtracting that from the first y point and from the first x point. So I know your graph doesn't have the colors on it on your sheet, but if we talk about, here's our x1 and our y1, talking about our first point, reading from left to right. Our x2 and our y2 is our second point. So our run is how far we go from this dot horizontally to we're underneath the other dot. That's what we call our run, or our change in x. We go from x1 to x2, it would be a number. If we go from this point, then we have to go up to meet our other dot, is going to be our rise, how much our y changes. We start at one y value, and we go up a certain number of units to the other. That's your rise or your change in y. So there's going to be different scenarios where some ways of finding your slope are better than others. And we'll talk about kind of when it's better to use one versus the other. Before we move into an example, this last bullet point was something you had on the quick notes yesterday. It says that if your slope goes up from left to right, so if it looks like you're going uphill, so something like if your graph is looking like this, that means your slope is positive. You have a positive slope. Think if you're trending upward, like your grades are going up, it's a positive thing. And then vice versa, if you have something that's going, we call it downhill or decreasing, this is what we'd be calling a negative slope. So we're going to keep that in mind as we're figuring out the actual value of these three below. So to find the slope of the line, when you're given a graph and you're giving points, the easiest way is just to count. Find the point that's farthest to the left and start there. So we're going to start this -3, -1. And what we're going to do is we're going to count up to we're even with this point, and then we're going to count over. So we're counting up. We have to go up 1, 2, 3, 4. 4 boxes. So I like to draw an arrow, and I'll do it in red. Let's say, okay, we went up 4. That's your change in y. Yeah. horizontally first? I can show you. It doesn't matter which way. You'll get the same thing either way. So we go up 4, and then we have to go to the right. And just like on a number line, whenever you go to the right, we take it as a positive thing. So we have to go to the right 1, 2, 3, 4, 5, 6. 6 squares. So we write plus 6. So our red number is your change in y, so we put that on the top. So we have 4 on the top. And then your blue number, or I guess my blue number, is your change in x, and that goes on our denominator. So that's 6. And then when we start doing math with these things, like multiplying and dividing, we always want the smallest numbers we can have here. So we're going to reduce this fraction whenever possible. We're going to reduce our slope. So 4/6 is the same thing as 2/3. 2 goes into 4 2 times. 2 goes into 6 3 times. So we can have this as written as a reduced fraction of 2/3, just making it smaller. So when we do have to do math operations on it, we're multiplying with smaller numbers. And then just to address May's really insightful question, why did I go horizontally first and then up? I always like to do my y first because I know that's the number that I'm going to put on the top. I like to write top to bottom. But I could go, if I go horizontally and then up, I'm still going over 6, and I'm still going up 4. So it doesn't matter which way you count from. It also doesn't matter, I could really start from here and count to this way. But instead, I'd be going down 4, so I'd be minus 4. And I'd be going to the left 6, so that's minus 6. And a negative 4 divided by a negative 6 is still going to get you a positive 2/3. So negative divided by a negative is a positive. I'll just add this piece in there too. So that's net minus 4 minus 6. So I'm just explaining this up now, putting in writing. Same thing, these two. So you can count up and to the right. You can write right and up, or you can count down and to the left. As long as you keep track of down and to the left is negative, up and right is always positive numbers. All right, with all that in mind, let's do B now. B, again, I suggest just looking to the point that's farthest to the left. And from there, I'm going to count down until I'm even with the other point. So I have to count down 1, 2 boxes. So I would write that as we have a change in y of minus 2. And then if we count over, we're going to the right, so it's going to be positive. 1, 2, 3, 4, 5. We're 5 boxes to the right, so write plus 5. So now we just have to write those numbers as a ratio, which is just to write it as a fraction. So we would say negative 2 divided by 5. And that fraction can't be reduced at all. It's not a number that evenly goes into 2 and 5. And one thing I'd always suggest doing is take a minute to say, okay, does it make sense that this is a negative slope, negative 2/5? Well, our graph is looking like it's going downhill. It goes down from left to right. So yes, it should be negative. So then moving to the third example, C, it should be, we know our slope should come out as a positive number. That's one thing we know for sure. One thing to notice on this graph, which is why I'm going to show an alternate way to do this, is that our boxes don't go up by just 1 anymore. It goes from 2 to 4. This one would be 6. So it's not going to work just by counting, okay, 1, 2, 3. Your scale is off. I don't like messing around with scales, all right? I like to count by ones when I can. I try to keep everything in ones. So what you can do in an example like this is take those points off of the graph. Say one of our points is 2, negative 3. And then our other point is 5, 4. And then we could use our information that we know about points. We know that these are x's and the second numbers are y's. And we're going to use those little subscripts, those tiny numbers that go below them, to show that this is our first point. This is x1 and y1. It's the first point we're talking about. This is our second point. So we're going to call it x subscript of 2 and y subscript of 2. If you look back to the piece on the top, we have a little formula up there. It says that to find the slope, we can take our y2 number and subtract it from our y1 number. So we could take y2 minus y1 and divide that by our x2 number taken away from our x1 number, because that's how you find change between two things. You subtract the difference and find the difference. It's nice if you are able to label your points and can remember this piece, because then you're just plugging in numbers. I know that my y2 is 4, so I'm going to plug a 4 in for y2. I know I'm subtracting, and I'm subtracting my y1 value, so I'm subtracting negative 3. I know my x2 value is 5. My x1 value is 2. So I'm writing 5 minus 2. Oops. So for our numerator, you could type this, if you just typed it on a calculator and spit out the right answer, if you were to do this in your head, you have to take 4 minus negative 3. Subtracting a negative turns into this, subtracting negative turns into an addition symbol or a chunky plus. So really we have 4 plus 3, which is 7. 5 minus 2, which is 3. And again, that's a slope that can't be simplified. There's not a number that evenly divides 7 and 3. I'm going to show another way to do it without the formula. If you can just have, I'm going to rewrite these points out. This is how on the key up here I was doing it. If you can connect, if you know what your two x values are, two x values go here and here. To get from 2 to 5, how many do I have to add? 3. So I can write like plus 3 here. To get from negative 3 to 4, how many do I have to add? 7. So here, I have the same representation. My change in y is 7, just like we got from doing the math. My change in x is 3, just like how we did from subtracting one from the other also. This way I like doing, just because it doesn't force me to remember this all the time. This, if I know my x and my y's and I know what slope is, you can do it all. So last piece are the tables. Tables we worked with before when we're trying to find out if something is linear. All things with this kind of slope form that we'll talk about the next 2 days, all these are always going to be linear. So we know there's already a pattern. We just have to compare the pattern of our x's and the patterns of our y's and our ratio. So our change in x each time, we're going up 3. Plus 3, plus 3, plus 3 each time for x. For our y each time, it's like you were doing yesterday with kind of how fast is Spotify downloading the songs. It's downloaded 45 songs a minute, so you subtracted 45 each time. But this time we're subtracting 6 each time. So you go minus 6, minus 6, minus 6. And tables are nice because it tells you which one is x and which one is y. Outputs are y, so our y is changing negative 6 each time. So that's going to be the top of our fraction. I should write these in, I should be consistent, put all these in blue since we're talking about change in x's. So our change of x, we're going up 3 each time. So I could put a positive 3 underneath here. Y is always on the top. So again, this is something we want to try to simplify. Negative 6 divided by 3 is going to give us a whole number. It'll give us negative 2. And it should be negative because our outputs are going down. If we were to graph this, we get a graph that's going down from 60 to 14. So what this is saying, for every 3 units, so every 3 units you count to the right, your y is going down 6. We do the same thing for the next one. Our inputs are x values. We're adding 3 each time. Our y values, we're just adding 1. So then our slope would be our change in y, which is positive 1, divided by our change in x, which is positive 3. And 1/3 can't be reduced either.